Pythagorean identities. Well, Pythagorean theorem says a squared plus b squared equals c squared. In this particular case, we're going to be talking about x squared plus y squared equals r squared. But when we're talking about trig, and we have some angle, we can refer to ratios of these three things. So someone realized, what if I divide the whole equation by x squared, y squared, or r squared? So let's do the most common one, the one that you probably definitely remember, is if you divide all of them by r squared, then you're going to get x squared over r squared, y squared over r squared, and this whole thing is going to end up being 1. Now, if you remember what x over r is, that's cosine. So we can write that as cosine squared of theta. Y over r is sine, so sine squared of theta equals 1. And this is very helpful. Many, many ways to ask you about this question, where sine plus cosine equals 1, or sine squared plus cosine squared equals 1. And it's not true that sine plus cosine equals 1. If we divide by, honestly, this is the only one of the three that I actually remember. And the other two, every time that I need to use them, I do the division out. So let's do the division out, which is literally what I do every time that I need to apply these identities. So I don't care which one we divide by first. We could divide by x squared. If we divide by x squared, what we get is 1 plus what's y over x? Well, that's tangent. So tangent squared of theta. Please remember that these have squares in them. Otherwise, these are not true statements. And r squared over x squared, that's hypotenuse over adjacent. So that is secant squared of theta. And it's worth pointing out that you can move the parts of this equation around, subtract 1 from both sides. You could try to factor some part of the equation. But you do need to know, at least when you start seeing something like tangent squared or secant squared, you should start thinking, ooh, is this a formula that I need to use? A third version, we've divided by r squared. We've divided by x squared. So now let's divide by y squared. This part becomes 1. R over y is hypotenuse over opposite, so that's cosecant. And x squared over y squared is cotangent squared of theta. Goodness, my writing. So cotangent squared of theta plus 1 equals cosecant squared of theta. So let's put those all on one page so that it's easier to remember. Sine squared plus cosine squared equals 1. So the next one was what? That tangent squared plus 1 equals secant squared. And then cotangent squared of theta plus 1 equals cosecant squared. Switching the order of the left and the right pieces doesn't matter. It does matter that the angles have to be the same. You can't say this if this were sine of theta plus sine squared of theta plus cosine squared of 90 minus theta. That no longer is a true statement. That equals 1. They have to be the same angles. They don't have to be just theta or just x in order for it to be true, but they do have to be the same angles in all of these cases. So what I recommend is know x squared plus y squared equals r squared, and then be ready to divide by whichever variable you need to. If you prefer, you're certainly welcome to memorize all 3 Pythagorean identities. Thanks.